Let's take a look at this limit here. When we have x going to infinity, e to the x also goes to infinity. And if x goes to infinity, of course, x goes to infinity. So this limit, the type of this limit is infinity over infinity, right? And that is an indeterminate form. And whenever we have an indeterminate form with infinity over infinity, for example, we should try to use L'Hopital's rule to get the answer. But I will just say that it's obvious this limit is infinity. Why? Because e to the x is an exponential function, and x is just a polynomial function. And an exponential function goes to infinity much, much faster than a polynomial does. So when I take e to the x, this exponential function, and divide it by little old x, it's not gonna affect it too much. E to the x is growing much, much faster. But formally, though, let's do it with L'Hopital's rule. And the reason, again, I'm allowed to use L'Hopital's rule is because it's infinity over infinity. That's one of the types that you're allowed to use L'Hopital's rule with, right? So L'Hopital's rule says that this limit is going to be the same as if I do the derivative of the top and the derivative of the bottom. The derivative of e to the x is e to the x, and the derivative of x is 1. Again, L'Hopital's rule here has nothing to do with quotient rule, right? This is a quotient, but we don't use the quotient rule for derivatives here. We just do the derivative of the numerator and the derivative of the denominator separately. Now, this over 1 is not really doing anything, so we just have the limit as x goes to infinity of e to the x. And e raised to large positive numbers, that's a very large positive number, so the answer is infinity. So remember the graph of e to the x, how it looks like? It looks something like this, right? And this is a number 1. So you can see as x goes to infinity, e to the x also goes to infinity. So there's our answer right there for this limit. The limit is equal to positive infinity.